We have learned that a normal distribution is determined by its mean, which is also mu, and standard deviation, which is also sigma. For a normal distribution, we can have different mean, we can have different standard deviation. So basically, we have unlimited number of combination of different mu's and different sigmas. So we have all kinds of normal distributions. In order to calculate the probability of distributions, of normal distributions, there are basically two methods. One, we use calculus. Basically, we use this formula here. Okay, we saw this before, all right? And we calculate the probabilities of normal distribution by taking the integrals of this fx here. Using this method take quite some time. So each time we have to calculate the integrals, and it's inconvenient in field use. So in this course, we're not gonna use this method. What we will do is we will use the second method, which is we use tables for normal distributions. Each time we need to find the probabilities, we look up the table. The advantage is it's very easy to use, it's convenient for field use. The challenge is we know there's many different kind of normal distributions. For each specific normal distribution, we need to have a specific table. So end of the day, we will have a lot of normal distribution tables. That's not convenient either. So the solution is we're going to have a standard normal distribution table, and we will use this standard normal distribution table to solve the probabilities of all kinds of normal distributions. In this session, we will focus on standard normal distribution table. In the next session, we will learn how to use the standard normal distribution table to solve probabilities of all other different kind of normal distributions. Let's focus on standard normal distribution table. And we're going to use a letter Z to designate the standard normal distribution variable. For all these standard normal distributions, we're going to have a mean equals to 0 and a sigma equals to 1. If you see, anytime you see a normal distribution with mean equals to 0, standard deviation equals to 1, that is a standard normal distribution. Now let's work on the probabilities of a standard normal distribution. We work on probability of Z bigger than A, smaller than B. Now, if it is bigger than A, smaller than B, then visually we can see that on this normal distribution. Visually, here is the normal distribution, and we'll have A here and B here. That's two different values. And the probability of Z bigger than A, smaller than B is always the size, the physical size of the highlighted area. Okay, so here's how we understand the probabilities. The probability is the physical size of the area between A and B. A quick note, in normal distribution, when we see probability of Z smaller or equal to A, it is basically equal to probability of Z smaller than A. If we see probability of Z bigger or equal to A, it is basically probability of Z bigger than A. There's the same thing, same value. Now, if we see probability of Z bigger than A, bigger or equal to A, smaller or equal to B, then it is basically probability of Z bigger than A and smaller than B. The reason is that the in normal distribution, probability of Z equal to any number equals to 0. This nature, in order to understand this nature, we have to get into calculus. So in this course, we don't require that. So basically, we just make it a rule that in normal distribution, we have all this properties. In the rest of this session, we're going to work on several examples. Here's the first example. The total probability, in other words, the physical size of the area under this curve and above the z-axis is always 1. Mathematically, we write it this way. Probability of z bigger than negative infinity, smaller than positive infinity, equals to 100%, equals to 1. So here, the normal distribution, the left tail stretches all the way to negative infinity, and the right tail, the tail on the right hand, goes all the way to positive infinity. So all the area under this curve above the z-axis equals to 1. The physical size of this area equals to 1. And that's something we have always have to remember. Okay, this is something we have to memorize. The probability under this curve above this line equals to 1. That is the total probability. And mathematically we write it this way. Now let's work on another example. We would like to know the probability of z bigger than negative infinity, smaller than 2.00. So visually it looks like this. It goes from negative infinity, which is the left-hand tail, all the way to z equals to 2, which is here. So we would like to know the probability, which is also the physical size of the highlighted area here. So mathematically, probability of z bigger than negative infinity, smaller than 2, equals to probability of z smaller than 2. We can skip this bigger than infinity part for convenience. Okay? Which we can simply write it this way. There is nothing special here. So this is what we need to know. Okay, here is the normal distribution table. It is the same thing as the one on the second page to the very end of this book. We're going to use this a lot, okay? And on the top row, we have z. And here we have 0.00, 0.01, 0.02, 0.03, goes all the way to 0.09. On the first column on the left hand, we have z 0.00, 0.01, and it goes all the way to 0.30. Actually, in our textbook, it goes all the way to 6.0. Okay. So let's learn how to use it. Now we're going to use this table to find the probability of z smaller or smaller than 2.00. What do we do is, let's slow down here. We're going to break down 2.00 here into 2.0 and 0.00. Basically, we're going to find 2.0 as the value to the first decimal point here. And then we have another one. This value is to the second decimal point of this one. Okay, so the row shows the value to the first decimal point, which is 2.0. So if we look at the first column of the table, we're gonna find goes all the way down to 2.0 here. Okay, and then in the first row here we find 0.00, which is the second decimal point value. So now we have 0.00 here. We go the cross of this 0.00 column and the 2.0 row here. We're going to find this column and this row crosses at this point, which is 0.9772, and that is the value for z smaller than 2.00, which is 0.9772. Again, what do? We break down this 2.00 to 2.0, which is the value to the first decimal point here, and 0.00, that is the value of the second decimal point. And then first decimal point, the value to the first decimal point, we find that in this column here, in the first column to the left hand, and the value to the of the second decimal point, we find that in this on the top, which is right here, and the cross of this column and this row here is the value we need. Now let's come back. What are we trying to do here? We're trying to find the value of probability z smaller than 2.0. Visually, as highlighted area in red here goes from the negative infinity all the way to 2. We try to find the physical size of this highlighted area. Using that table, the normal distribution table, we found that the physical size of this area is 0.9772.